Hello, what's up guys? So this is day 3 of our programming journey, and in this video I'm going to talk about the platform independency of Java. Why and how Java is platform independent. In the previous video I've already given you a brief about the platform independency in Java. However, in this video we'll look into the details of that part. So without wasting any time, let us get started. Before that, let us look into the execution of the C program. Okay, how a program is executed in the C language. All right. So whenever we write any C program, we save it using .c extension, and whenever that program is compiled, uh, a machine code is produced or an executable is produced, which is by the name test.exe. Now this machine code can be run, and upon running we will be able to get the desired output. Now even if we delete this file and if we still have this file, and upon running this file we'll still able to get the desired output. All right, let us look into the details. So this is how a program is executed actually. These are the hardware: CPU, monitor, keyboard, mouse, etc. And this is the operating system which is inside the main memory, and the program is also running inside the main memory. Alright. So whenever we double click on any application, alright, so that application is run over the operating system. Alright, and that program which is running on the operating system communicates with the operating system to use the hardware, okay, to use the monitor for for example printing any output, to use the keyboard for detecting any inputs. All right, so as you can see over here, this is the hardware. On top of the hardware there is the operating system, and on top of the operating system there is this program. Now program cannot directly communicate with the hardware. Alright, it has to first communicate with the operating system, and then in turn operating systems give its messages to the hardwares. Alright, so the the part where the program communicates with operating systems is called as system calls. That is, the program makes the system calls to use the resources of this operating system, that is the hardwares, that is in order to print some output on the screen, to detect any input changes, etc. All right, so let us look into how Java is compiled. All right, we have already seen that, but I'll just give you a brief about the same. So whenever any Java program is compiled, a dot class file is produced. So please take a note that this dot class file which is produced by the compiler is a bytecode. It is an intermediate code. It is not an executable file, or it is not a machine code. That is, it does not consist of zeros and ones. Therefore, a JVM is required in between the bytecode and the bytecode and the operating systems. This JVM takes the input as the bytecode and produces line by line machine code for the same. Since it is an interpreter, so the working of the interpreter is to take single line as input and produce single line as the output. All right. So I hope you have understood till here. Let us look into the further pictures like how Java is compiled. So, as we have seen earlier, in case of the C language, the program was directly able to communicate with the operating system. All right. However, in case of Java, there is a JVM sitting in between. Now, why is there a JVM sitting in between? Since this is the bytecode which is produced by the Java's compiler, it does not consist of machine code. It does not consist of zeros and ones. Now the operating systems which is present over here can only understand the machine code. That is, it can only understand zeros and ones. So this program first gets compiled, and then it is passed on to the JVM, where the JVM produces the machine code for the same, and this machine code is understood by the operating system, and whatever the command JVM has sent to the operating system, further it would be sent ahead to the hardware, that is to display any output or to detect any input changes, anything like that. All right, so now over here, this operating system is running in the main memory, and inside it the JVM is running. Now inside JVM our program is also running. All right. So if our program wants to use any resources of this hardware of this operating system, that is use monitor or detect input changes, etc. Now this program firstly will communicate with the JVM. Okay. Now in turn the JVM will communicate with the operating systems. All right. So and will the operating system, upon receiving inputs from the JVM, will allocate resources and will assign resources to this program. All right. So JVM sits in between the operating system and the program. All right. Uh, Now JVM communicates with the operating systems, and this portion is actually called as Java APIs. All right. So let us look ahead. Now, in case of the C language, when the C program is compiled, a .exe file is produced. All right. Now, suppose if we are running a C program in the Windows operating system. Now, upon compilation, a .exe file would be produced for the Windows operating systems. All right. Now, this .exe file cannot be run in Linux operating systems, and this is because of the system calls. All right, the system calls over here. Now, this system calls in case of the C program are specifically designed to communicate with the Windows operating system. They are not designed to communicate with the Linux operating systems. All right. So whenever a .exe file is produced upon compilation of the C program, that that would be only running on this Windows operating system. It cannot be run in Linux or Mac operating systems. All right. Similarly, if a .exe file is produced in the Linux operating system, well, upon compilation of the C program, it cannot be run on the Windows or it cannot be run in the Mac operating systems. All right. Now that is not the case with Java, as JVM sits in between the bytecode and the operating system. All right, that is this program and the operating system. All right. So whenever we compile a Java program, a dot class file is produced. This dot class file is nothing but the intermediate code or the bytecode. Now this bytecode has to be passed to the JVM, and now JVM in turn system calls with the Windows operating system or with the Linux operating system. Now this input to the JVM is a bytecode. All right. JVM doesn't care if the bytecode is coming from the Windows operating system or the Linux operating systems. All right. It just wants its bytecode, and based on the bytecode, it will make system calls with the Windows operating system or the Linux operating system. Now, one more thing to remember, this JVM is, for example, there is a JVM running on the Windows operating system. It will be different from the JVM running on the Linux operating system. For example, this JVM will have system calls for the Windows operating system. This JVM will have system calls for the Linux operating system. This JVM doesn't care, okay, like from which operating system the bytecode is coming. It simply wants its bytecode, and based on its bytecode, it will communicate with the respective operating systems. All right. So the JVMs are different for different machines. All right. So as we have already seen, that is, it will make system calls for the Windows operating system. Since this JVM doesn't care from where its bytecode is coming, therefore the Java is platform independent. All right. Since this JVM can execute bytecode coming from any operating system, all right, like Windows or even Mac or Linux, etc. All right. Now the compiler's job is simply to compile the program, check for the semantics error, and produce the bytecode. It doesn't depend, like this compilation doesn't depend on whether it is in the Windows or whether it is on the Linux or whether it is on the Mac. All right, its job is to simply produce the bytecode for the same, and the JVM's job is simply to take that bytecode coming from any interpreter and making the system call with its respective operating systems. All right. So because of this JVM, the Java is platform independent. All right. Um, so now let us understand why Java is platform independent. All right. So in the early 19th century, when the internet was still developing, there was a need for the companies to to have their internal machines communicate with each other and to have their internal machine share programs with each other. All right. Suppose this is a huge company and there are four machines in it, and this machine wanted to share program with all these machines. All right. And let us take an example that this company was using C language to develop some software system. All right. So if the program was developed on this machine, it cannot be shared on this machine. All right. As the C language upon compilation will have system calls only specific to this machine. All right. Therefore, the program which was developed by this machine cannot be run on any of these machines. All right. So there was a compatibility issue between sharing the programs. Okay, so there was a need for a programming language which can be written over here. Okay, which can be written over here and can be shared all across and can also be run smoothly all across this machine. So this led to the development of the Java programming language. All right, so Java is write once. That is, it can be written over here and can be read over anywhere. Okay, all right. So this was all about this video. I hope you like it and thank you for watching. Thanks a lot.